Hello guys, and welcome back to the Sleepy Universe channel, to the series for you to fall asleep to, and where we discover all planets of our solar system. Today we will talk about Saturn, the majestic ringed giant that drifts quietly in the outer solar system, wrapped in bands of pale gold and surrounded by one of the most breathtaking structures in our cosmic neighborhood. You drift slowly outward from the warmth of the inner planets, moving beyond Mars and Jupiter until a large, softly glowing world appears in the distance, crowned by shimmering rings that stretch far beyond its visible edge. Saturn is the sixth planet from the Sun. It orbits far from the warmth of Earth's neighborhood. Saturn orbits the Sun at an average distance of about 1.4 billion kilometers. From afar, Saturn appears calm and elegant, its rings forming a thin, luminous halo. Saturn is the second largest planet in the solar system. Only Jupiter surpasses it in size. As you drift closer, you begin to sense its immense scale. Saturn has a diameter of about 120,500 kilometers, more than 9 Earths could fit across its width. Yet, despite its size, Saturn feels light in a surprising way. Saturn is the least dense planet in the solar system. Its average density is so low that in theory, it could float in a vast enough ocean. Saturn is less dense than water. You sense how this giant world is not solid like Earth. There is no surface to stand on, no ground to touch, only layers of gas growing denser as you descend. Saturn is a gas giant composed mostly of hydrogen and helium. Bands of clouds circle the planet, subtle in color compared to Jupiter's bold stripes. Saturn has visible atmospheric bands. These bands are shaped by powerful winds. Winds on Saturn can reach speeds of over 1,800 kilometers per hour. You drift slowly beside this golden world, watching its rings shimmer in sunlight, sensing that Saturn is not only beautiful, but complex, massive, and quietly powerful. A planet that holds storms, moons, and mysteries within its vast and graceful presence. And you remain calm and weightless, ready to drift deeper into the story of Saturn's rings and hidden depths. You continue drifting closer to Saturn, allowing the immense planet to slowly fill your awareness, and you begin to notice how its soft golden hues are created not by solid ground, but by layers of clouds suspended deep within its vast atmosphere. Saturn's atmosphere is composed of about 96% hydrogen and 3% helium. Trace amounts of methane and ammonia give the clouds subtle coloration. Methane in Saturn's atmosphere contributes to its pale yellow appearance. Unlike Jupiter, Saturn's bands appear more muted. Saturn's cloud bands are less colorful than Jupiter's. This is partly because Saturn's upper atmosphere contains thick haze layers. Saturn has a thick atmospheric haze. You drift slowly along the planet's equator, where something unusual becomes visible. A faint geometric shape in the clouds, a pattern that should not exist in nature, yet it does. Saturn has a massive hexagon-shaped storm at its north pole. This hexagon is not small, it is enormous. The hexagon on Saturn is about 30,000 kilometers wide, large enough to fit multiple Earths inside it. You sense how this six-sided jet stream has persisted for decades. Saturn's north polar hexagon has been stable for over 30 years. It rotates with the planet, maintaining its shape. A storm, perfectly geometric, silent, enduring. You drift toward the South Pole. There, another powerful system churns. Saturn has a hurricane-like storm at its south pole. Unlike the hexagon, this storm resembles a massive cyclone. At its center lies a clear eye. Saturn's south polar storm has a well-defined eye. You sense how Saturn's atmosphere is not quiet. It is alive with motion, rising gases, descending currents, rapid rotation. One day on Saturn lasts about 10.7 Earth hours. This rapid spin causes the planet to bulge outward at the equator. Saturn is noticeably flattened at the poles. You drift slowly across the equatorial bulge, sensing how rotation shapes not only storms, but the planet's entire structure. And as you remain suspended beside this softly glowing giant, you feel how Saturn is both serene and powerful at once. A world of swirling winds, geometric storms, and endless motion hidden beneath calm golden clouds. You drift slowly outward from Saturn's cloud tops, letting your awareness expand beyond the swirling atmosphere and into the space surrounding the planet. And as you do, the rings begin to dominate your view, stretching outward in delicate, luminous arcs that seem almost impossibly thin compared to their vast width. Saturn's rings are the most extensive and complex ring system in the solar system. From a distance, they appear solid, like a single continuous disk, but as you move closer, you begin to sense that they are made of countless individual pieces, each one orbiting Saturn in perfect gravitational balance. Saturn's rings are composed primarily of water ice. Mixed within the ice are traces of rock and dust. The ring particles range in size from tiny grains to chunks as large as mountains. Some pieces are no bigger than sand, others are hundreds of meters across. You may begin to feel how thin the rings truly are. Although Saturn's rings span over 280,000 kilometers across, they are only about 10 to 100 meters thick in most places. This contrast between width and thickness makes them feel almost fragile, almost weightless, and yet they are real, held together by gravity. You drift across the major ring divisions, bright bands, dark gaps, subtle separations. Saturn's rings are divided into several main sections, including the A, B, and C rings. Between them lies a wide, dark gap. The Cassini division separates the A and B rings. This gap is not empty. It contains fewer particles, shaped by the gravitational influence of nearby moons. You begin to sense how Saturn's moons interact with the rings, pulling, shepherding, carving gaps. Some of Saturn's moons act as shepherd moons that shape the rings. These moons keep ring particles confined to narrow bands. Without them, the rings would slowly spread and thin out. You drift quietly along the outer edge of the ring system, watching sunlight scatter off billions of icy fragments, each reflecting a soft glow back into space. And you begin to feel how Saturn's rings are not permanent structures. They evolve, they change, they may even disappear one day. Saturn's rings are thought to be relatively young, possibly less than 400 million years old. Compared to Saturn itself, they are recent, temporary, a brief adornment in cosmic time. As you remain calm and weightless beside this ringed giant, you sense how Saturn is not only defined by its size or storms, but by this extraordinary structure that encircles it, a luminous crown of ice and stone drifting silently through the dark, fragile and magnificent all at once. You drift even farther outward now, letting the full breadth of Saturn and its rings settle into your awareness, and you begin to sense how this planet is not merely a gas giant with decorative bands of ice, but a gravitational center of its own vast and intricate system, quietly holding dozens of moons and billions of ring particles in delicate balance. Saturn has more than 140 known moons and moonlets. Some are tiny, irregular fragments. Others are massive worlds in their own right. Each one orbits within Saturn's powerful gravitational influence. You sense how Saturn's gravity shapes not only its rings, but the entire region around it. Saturn's gravity strongly influences nearby objects in the outer solar system. Its mass is immense. Saturn is about 95 times more massive than Earth, yet its density remains surprisingly low. Saturn's average density is about 0.69 grams per cubic centimeter, less than water. You may begin to feel how Saturn formed early in the solar system's history. Saturn formed about 4.5 billion years ago. Like Jupiter, it likely began as a solid core that rapidly attracted surrounding gas. Saturn likely formed through core accretion. Once its core grew large enough, hydrogen and helium flooded in. The planet expanded, its gravity strengthened, its atmosphere deepened. You drift slowly along Saturn's equator, watching cloud bands blur gently due to its rapid rotation. Saturn's rapid rotation contributes to its flattened shape. This flattening is more extreme than Earth's. You sense how Saturn is not a solid object beneath its clouds. The deeper you imagine descending, the more pressure increases. Gas becomes liquid, liquid becomes metallic. Deep inside Saturn, hydrogen may exist in a metallic state. This metallic hydrogen likely contributes to Saturn's magnetic field. Saturn has a powerful magnetic field. Though not as strong as Jupiter's, it is still immense, invisible, protective, dynamic. You drift slowly backward now, letting Saturn's full scale rest in your awareness, its rings shimmering softly, its atmosphere swirling gently, its moons orbiting in silent harmony, and you begin to feel how Saturn is both immense and graceful at once, a giant that moves with quiet elegance through the darkness of space. And as you remain calm and weightless beside this ringed world, you sense that this is only the beginning of Saturn's story, that beyond its clouds and rings lie deeper mysteries waiting patiently to be explored. Part 2. The Architecture of the Rings. You drift slowly outward once more, allowing Saturn itself to fade slightly into the background, while its rings expand across your entire field of view, stretching wide and luminous like a frozen wave of light suspended in space. And you begin to sense that these rings are not random debris, but a carefully structured system shaped by gravity, motion, and time. Saturn's rings extend up to about 280,000 kilometers from the planet. They form a vast, flat disk encircling the equator. From afar, they look smooth, continuous. But as you move closer, you begin to notice gaps, ripples, braided strands. Saturn's rings are divided into thousands of smaller ringlets. Each ringlet consists of countless particles. Each particle follows its own orbit. You may sense how these particles are constantly moving, never resting, never colliding gently. Instead, they interact through gravity and subtle impacts. Ring particles orbit Saturn at different speeds depending on their distance. Closer particles move faster. Farther particles move slower. This creates shear forces, wave patterns. Spiral density waves ripple through the rings. Gravitational interactions create spiral density waves in Saturn's rings. These waves are caused by the gravitational pull of Saturn's moons. You drift toward a narrow ring that appears sharply defined. The F ring is one of Saturn's narrow outer rings. This ring is shaped by two small moons. Prometheus and Pandora act as shepherd moons for the F ring. Their gravity keeps the ring confined. Without them, the particles would gradually spread outward. You sense how Saturn's rings are not static decorations. They are dynamic systems, constantly adjusting, constantly interacting. You drift toward the innermost rings. They appear darker, more diffuse. The C ring is more transparent than the A and B rings. Light passes through it more easily. Beyond it lies the densest region. The B ring is the brightest and most massive ring. It contains the majority of the ring material. You may begin to feel how the rings are thin beyond imagination. Saturn's rings are incredibly thin compared to their width, in many places only tens of meters thick, yet stretching wider than Earth's diameter many times over. You sense how fragile they truly are, not solid, not permanent, but constantly reshaped by gravitational nudges and tiny collisions. And as you drift slowly through this immense architecture of ice and motion, you remain calm and weightless, aware that Saturn's rings are not just beautiful, but structured, organized, and delicately balanced, a masterpiece of gravity quietly orbiting a giant world in the dark. You drift slowly deeper into the structure of Saturn's rings, allowing your awareness to settle into the fine details of this vast and delicate system, and you begin to sense how even within what appears to be a simple band of ice, there are countless layers of complexity hidden in motion and interaction. The B ring contains most of the mass of Saturn's ring system. It is dense, bright, and thick compared to the other rings. Yet even here, particles are separated by small gaps. They are not tightly packed like solid ice. They are individual bodies orbiting in shared harmony. Ring particles constantly collide with one another. These collisions are usually gentle. They prevent the particles from clumping together into a moon. You sense how the rings are balanced between gathering and dispersing. Gravity pulls particles together. Orbital motion pulls them apart. The balance between gravity and orbital motion keeps the rings stable. You drift toward a sharp gap in the rings. It appears almost cleanly carved. The Cassini division is about 4,800 kilometers wide. This division exists because of gravitational resonance. The moon Mimas creates a gravitational resonance that helps maintain the Cassini division. At specific orbital ratios, particles are repeatedly tugged. Over time, these tugs clear out material. You begin to feel how resonance shapes structure, not through force, but through repetition, a small pull, again and again, until a gap appears. You drift across narrow ringlets that twist slightly. Some appear braided. The F ring contains braided structures. These braids are caused by the shifting gravity of nearby moons. You sense how Saturn's moons are architects, invisible sculptors, carving patterns into ice, maintaining boundaries, shaping beauty. You drift outward toward faint outer rings. They are harder to see, more diffuse. Saturn has faint outer rings beyond the main ring system. These rings extend much farther than once believed. In fact, one of them is enormous. Saturn has a massive faint ring known as the Phoebe ring. This ring stretches millions of kilometers outward. You begin to feel how Saturn's ring system is not a simple disk. It is layered, dynamic, expansive, a gravitational artwork slowly evolving over time. And as you remain suspended among these icy fragments, watching sunlight scatter softly from particle to particle, you feel how Saturn's rings are not merely decorative, but alive with motion, quietly responding to every gravitational whisper in the vastness of space. You drift slowly along the outer edges of Saturn's luminous ring system, allowing your awareness to widen beyond the main bright bands and into the more subtle, almost invisible structures that extend far into space. And you begin to sense how Saturn's rings are not isolated features, but part of a larger, evolving environment shaped by time, gravity, and quiet decay. Saturn's rings are gradually losing material. Tiny particles fall inward toward the planet. This process is slow, almost imperceptible, but constant. Scientists call this process ring rain. Charged particles from the rings spiral along magnetic field lines and enter Saturn's atmosphere. Over immense spans of time, this rain will thin the rings. You may begin to feel how Saturn's rings are temporary on cosmic scales. Saturn's rings may disappear within the next 100 to 300 million years. Compared to Saturn's age, this is brief, a passing phase, a moment of brilliance. You drift toward a region where small clumps of material appear to gather. Some ring particles temporarily clump together due to self-gravity. These clumps may form moonlets, tiny worlds only meters or kilometers across. But tidal forces from Saturn prevent most from growing large. Saturn's tidal forces prevent large moons from forming within the main rings. You sense how the rings exist inside a boundary known as the Roche limit. Saturn's main rings lie within Saturn's Roche limit. Inside this distance, tidal forces overpower the gravity that would normally pull particles into a moon, so the rings remain fragmented, scattered, endlessly orbiting. You drift through a thin region where waves ripple outward in concentric patterns. Density waves propagate through Saturn's rings. These waves are triggered by gravitational resonances with moons. They move through the rings like sound waves move through air. Subtle, precise, beautiful. You begin to feel how Saturn's rings are not frozen in place. They shift, they evolve, they respond. Every moon's orbit slightly alters their structure. Every small collision redistributes momentum. You sense how fragile the system truly is. Remove a moon, shift a resonance, wait millions of years, and the rings would look different. As you float quietly among these drifting fragments of ice and stone, you remain calm and weightless, aware that Saturn's rings are not eternal crowns, but evolving structures caught in a delicate balance of gravity and time, shining brightly for now in the vast darkness of space. You drift slowly back towards Saturn itself, letting the full ring system settle into a single luminous plane encircling the planet. And you begin to sense how these rings are not merely structures of ice and stone, but chapters in a much larger story about destruction, creation, and the quiet recycling of matter in the outer solar system. Saturn's rings may have formed from a shattered moon. One possibility is that a former icy moon drifted too close, crossed the Roche limit, was torn apart by tidal forces, its fragments spreading into orbit. Tidal forces can rip apart celestial bodies that cross the Roche limit. Another possibility is that a passing comet broke apart, its debris captured by Saturn's gravity. captured comet material may have contributed to the rings. You sense how Saturn's rings are not separate from its moons. They are connected. Some moons may have formed from ring material. Some ring material may have come from moons. There is ongoing exchange of material between Saturn's rings and its moons. This exchange blurs the line between ring and satellite. You drift toward the edge of the B ring again, noticing faint spokes that seem to appear and fade. Spoke-like features have been observed in Saturn's rings. These spokes are temporary, likely formed by interactions between ring particles and Saturn's magnetic field. You begin to feel how Saturn's magnetic influence extends even into the ring plane. Invisible forces shaping visible structures. You sense how sunlight interacts with the rings as well. When the sun strikes them at low angles, shadows stretch across the ring plane. Seasonal changes affect the illumination of Saturn's rings. As Saturn orbits the sun, the tilt of the rings changes from Earth's perspective. Sometimes we see them wide open, sometimes nearly edge-on. Saturn's rings tilt about 27 degrees relative to its orbit. There are moments when they almost disappear from view, thin, knife-like, barely visible. And then they return, wide, brilliant, radiant. You begin to feel how Saturn's rings are not static ornaments, but evolving systems influenced by gravity, magnetism, sunlight, and time, constantly reshaped in subtle ways that unfold across millions of years. As you remain suspended in the quiet darkness beside this ringed giant, watching its icy halo shimmer softly, you sense that Saturn's beauty is not permanent, not fixed, but part of an ongoing cosmic cycle where matter gathers, breaks apart, reforms, and slowly drifts through the vast and patient expanse of space.
Part 3. The Kingdom of Moons. You drift slowly beyond the shimmering rings, allowing your awareness to expand into the vast gravitational realm surrounding Saturn, and you begin to sense that this planet is not alone, not solitary, but the center of a vast and intricate system of moons, each one orbiting in quiet loyalty around the ringed giant. Saturn has more than 140 known moons and moonlets. Some are small and irregular, captured fragments of rock and ice. Others are enormous, complex worlds in their own right. You drift toward the largest of them all, a massive golden sphere wrapped in thick haze. Titan is Saturn's largest moon. It is not small. Titan is larger than the planet Mercury. You sense how unusual Titan is. Unlike most moons, it has a thick atmosphere. Titan has a dense, nitrogen-rich atmosphere. Its surface is hidden beneath orange smog. Beneath that haze lie rivers, lakes, seas, but not of water. Titan has lakes and seas of liquid methane and ethane. You begin to feel how Titan resembles a strange frozen version of early Earth. Organic chemistry occurs in its atmosphere. Complex molecules form. Titan's atmosphere contains complex organic molecules. You drift farther outward to another moon, bright, icy, crisscrossed with fractures. Enceladus is one of Saturn's most geologically active moons. At its south pole, something remarkable happens. Enceladus ejects plumes of water vapor and ice into space. These geysers feed Saturn's E-ring. Material from Enceladus contributes to the E-ring. You sense how Enceladus hides a secret beneath its ice shell. Enceladus has a subsurface ocean beneath its ice shell. This ocean may contain the ingredients necessary for life. You drift toward another moon, dark on one side, bright on the other. Iapetus has a dramatic two-tone coloration. One hemisphere is coated in dark material, the other shines with ice. You sense how Saturn's moons are not uniform. Each one is unique. Each one holds its own story. You drift across a cluster of smaller moons embedded within the rings. Some of Saturn's moons orbit within the ring system. These moons sculpt the rings as they travel, carving gaps, maintaining edges. You begin to feel how Saturn is less a single planet and more a miniature solar system, a central giant surrounded by orbiting worlds, each influenced by gravity, each connected through motion. As you remain calm and weightless within Saturn's kingdom of moons, you sense that this system is vast and alive with diversity. Icy oceans, methane lakes, fractured crusts, and drifting fragments, all quietly circling the ringed giant in endless cosmic harmony. You drift slowly deeper into Saturn's vast system of moons, allowing your awareness to move from one orbit to another, and you begin to sense how each moon is shaped not only by its own composition, but by its constant gravitational relationship with Saturn and with neighboring moons. Titan is the only moon in the solar system with a thick atmosphere. Its atmosphere is even denser than Earth's. Titan's surface pressure is about 1.5 times that of Earth's. This thick atmosphere allows weather to occur. Clouds form, rain falls, rivers carve channels. Titan has an active methane cycle similar to Earth's water cycle. You sense how methane evaporates from lakes, forms clouds, and returns as rain. But unlike Earth, the temperature is extremely low. Titan's surface temperature is about -179 degrees Celsius or -290 degrees Fahrenheit, cold enough for methane to behave like water. You drift back toward Enceladus, small compared to Titan, bright and icy, yet astonishingly dynamic. Enceladus is only about 500 kilometers in diameter. Despite its size, it releases enormous plumes into space. The plumes of Enceladus contain water vapor, ice particles, and organic compounds. These plumes suggest internal heat. Tidal heating powers Enceladus's internal activity. Saturn's gravity stretches and compresses the moon, creating friction, generating warmth. You begin to feel how Saturn's gravitational pull does more than hold moons in orbit. It reshapes them, warms them, energizes them. You drift toward Rhea, a heavily cratered icy world. Rhea is Saturn's second largest moon. Its surface preserves ancient impacts, frozen in time. You sense how some moons are quiet and old, others active and young. Some may harbor oceans, some may be solid ice throughout. Several of Saturn's moons may contain subsurface oceans. These hidden oceans exist beneath thick ice shells, heated by gravitational forces. You begin to feel how Saturn's moon system is incredibly diverse. Rocky fragments, icy spheres, atmospheric worlds, ocean-bearing moons. As you float gently among these orbiting bodies, you remain calm and weightless, aware that Saturn's realm is not defined by the planet alone, but by this extraordinary family of moons, each one shaped by gravity, time, and quiet cosmic forces, circling endlessly through the darkness. You drift slowly farther outward through Saturn's vast gravitational domain, letting the larger moons fade gently into the background while smaller, more irregular bodies begin to emerge. And you begin to sense how this system extends much farther than the bright rings and well-known satellites first suggest. Many of Saturn's outer moons are irregular in shape. Unlike Titan or Rhea, these moons are not spherical. They are jagged, uneven, often captured objects. Several of Saturn's distant moons were likely captured asteroids or Kuiper Belt objects. These moons orbit at steep angles. Some even move in the opposite direction of Saturn's rotation. Some of Saturn's moons have retrograde orbits. You sense how these distant moons do not follow the orderly pattern of the inner system. Their paths are elongated, inclined, sometimes chaotic over long timescales, yet they remain bound to Saturn's gravity. You drift through a region where small moonlets orbit within the rings themselves. Saturn has tiny moonlets embedded inside its rings. These moonlets create propeller-shaped disturbances, subtle disruptions in the ring material. Moonlets can create propeller features in the rings. These disturbances reveal how even small bodies can shape vast structures through gravity alone. You begin to feel how Saturn's system resembles a miniature solar system, a central massive body, rings like flattened debris disks, moons like planets in orbit, each one interacting gravitationally with the others. Saturn's moon system provides insight into how planetary systems form. The processes shaping these moons mirror processes that shaped the early solar system: accretion, collision, capture, migration. You drift toward the faint Phoebe ring, almost invisible, yet immense. The Phoebe ring extends millions of kilometers from Saturn. It is associated with the moon Phoebe, dark, irregular, captured long ago. You sense how material from Phoebe slowly spirals inward, some of it coating Hyperionus's dark hemisphere. Material from Phoebe likely contributes to Hyperionus's dark surface. Gravity connects everything here. Nothing exists independently. Every moon, every ring particle, every fragment, all moving in response to Saturn's massive pull. As you float calmly within this immense and interconnected system, you remain weightless and peaceful, aware that Saturn's kingdom is not just a planet with companions, but a dynamic gravitational ecosystem where ice, rock, and time weave together in silent, endless motion. You drift gently back toward the center of Saturn's vast system, letting the distant, irregular moons fade into darkness, while the larger inner moons continue their steady, graceful orbits. And you begin to sense how this entire celestial family exists in delicate balance, each body following precise paths defined by gravity and time. Saturn's moons orbit in stable gravitational resonances. Some moons influence each other through repeated orbital alignments. These resonances maintain order, prevent chaos, shape long-term stability. You sense how certain moons are locked in synchronized motion. Some of Saturn's moons are in orbital resonance with one another. This means their orbital periods form simple numerical ratios, a quiet rhythm, repeated endlessly. You drift back toward Titan once more, massive, shrouded, complex. Titan contains more liquid hydrocarbons on its surface than Earth contains oil reserves. Its seas stretch across polar regions. Its rivers carve channels. Its atmosphere hides the surface beneath orange haze. You feel how Titan alone could be a world worthy of deep exploration, and yet it is only one member of Saturn's family. You sense how Enceladus, small yet active, continues to eject plumes. Enceladus ejects material at speeds that allow it to escape the moon's gravity. Some of this material falls back, some escapes into Saturn's orbit, some may even drift away into space. You begin to feel how Saturn's moon system is dynamic, not frozen. Moons exchange material. Tidal forces reshape surfaces. Gravitational pulls subtly alter orbits over millions of years. Tidal interactions slowly change the orbits of Saturn's moons. Some moons are gradually moving away from Saturn, ever so slowly, over immense timescales. You drift gently between Titan and the rings, sensing how Saturn's system is layered. Inner rings, shepherd moons, mid-sized icy worlds, massive Titan, and then distant captured fragments. A hierarchy of motion, a structure built by gravity. You begin to feel how Saturn is not merely surrounded by moons, but sustained by them in a cosmic dance that has unfolded for billions of years. As you remain calm and weightless in this vast orbital ballet, you sense that Saturn's kingdom of moons is not static or silent, but alive with motion and interaction, a grand celestial system where ice, rock, and gravity move together in slow, endless harmony around the ringed giant. Part 4. Storms beneath the clouds. You drift slowly back toward Saturn itself, leaving the quiet choreography of its moons behind, and as the planet grows larger in your view, you begin to sense that beneath its soft golden appearance lies an atmosphere far more dynamic and powerful than its gentle colors suggest. Saturn's atmosphere is composed primarily of hydrogen and helium. These light elements form deep, thick layers that extend thousands of kilometers downward. Unlike Earth, Saturn has no solid surface marking a clear boundary between sky and ground. Saturn does not have a solid surface. As you descend through imagination, clouds grow denser, pressure increases, light fades. You sense vast atmospheric layers stacked one upon another. Saturn's atmosphere contains multiple cloud layers. The upper clouds are made mostly of ammonia ice. Ammonia ice forms the highest visible cloud layer on Saturn. Below that, deeper clouds of ammonium hydrosulfide form. Saturn has ammonium hydrosulfide cloud layers beneath the ammonia clouds. Even deeper still, water clouds may exist. Water clouds likely form in Saturn's deeper atmosphere. You begin to feel how Saturn's storms are fueled by internal heat. Unlike Earth, Saturn radiates more energy than it receives from the Sun. Saturn emits more heat than it receives from solar radiation. This internal heat drives convection. Warm gases rise, cool gases sink, storm systems develop. You drift toward the equator. Cloud bands stretch endlessly around the planet. Winds on Saturn can exceed 1,800 kilometers per hour near the equator. These winds are among the fastest in the solar system. Yet despite these speeds, Saturn's colors remain soft and muted. You sense how haze layers blur the contrasts. Saturn's upper atmosphere contains photochemical haze. Sunlight interacting with atmospheric gases creates this haze. It softens the visible bands. But beneath the haze, storms churn continuously. You drift toward the North Pole again. The hexagon becomes visible, perfectly geometric, impossible at first glance. Saturn's north polar hexagon is a six-sided jet stream. It rotates with the planet, maintaining its shape for decades, perhaps longer.
You begin to feel how Saturn's atmosphere is not random chaos. It is structured, layered, powered by rotation and internal heat, a system of rising and sinking gases, of jet streams and vortices, of quiet beauty hiding immense energy. As you float gently above these golden cloud tops, watching sunlight scatter softly across their rippling texture, you remain calm and weightless, aware that beneath Saturn's serene exterior lies a world of powerful winds, deep convection, and long-lived storms slowly unfolding across an endless sea of gas.
You drift gently deeper into Saturn's atmosphere, letting the upper haze fade as your awareness moves into regions where sunlight grows dim and pressure steadily increases, and you begin to sense how this immense gaseous world is layered like an ocean without a shore, where depth replaces distance and gravity quietly compresses everything below. Pressure increases rapidly as you descend into Saturn's atmosphere. Within only a few hundred kilometers, pressure becomes many times greater than Earth's surface pressure. Gas thickens, movement slows, light fades into a golden twilight. You sense how Saturn's rapid rotation shapes everything here. Saturn rotates once every approximately 10.7 hours. This rapid spin stretches the planet outward at its equator. Saturn is significantly flattened at the poles due to its fast rotation. The equatorial diameter is thousands of kilometers wider than the polar diameter. You begin to feel how rotation also strengthens jet streams. Saturn's jet streams create alternating east-west wind bands. These bands form boundaries between atmospheric cells. Where warm gas rises, cool gas sinks, storm systems form along these boundaries. You drift toward a bright disturbance in the clouds, a massive pale eruption expanding outward. Saturn experiences periodic great white spot storms. These storms are enormous. They can wrap around the entire planet. The great white spot appears roughly once every Saturnian year. A Saturnian year lasts a long time. 1 year on Saturn is about 29.5 Earth years, so these giant storms are rare, but powerful. You sense how lightning flashes deep within thick water clouds. Lightning has been detected in Saturn's atmosphere. Some of these lightning bolts are far more energetic than those on Earth. Thunder would echo endlessly if there were air like ours to carry it. You begin to feel how Saturn's internal heat feeds these storms from below. Warm material rises from deep layers, cooling and condensing as it ascends. Convection drives Saturn's major storm systems. Unlike Earth, where sunlight drives most weather, Saturn's weather is powered largely from within. You drift lower still in imagination. Gas becomes denser. Hydrogen molecules are squeezed closer together. Eventually, under immense pressure, something extraordinary happens. At great depths, hydrogen may transition into a liquid state. Farther still, even more extreme conditions exist. Deep within Saturn, hydrogen may become metallic. In this state, hydrogen conducts electricity. This movement generates Saturn's magnetic field. You begin to feel how Saturn's atmosphere is not merely clouds and wind, but the visible skin of a much deeper, more powerful structure, where heat, pressure, and rotation combine to create a living, shifting ocean of gas thousands of kilometers deep. And as you remain calm and weightless within this imagined descent, you sense that Saturn's storms are only the visible expression of a vast internal engine quietly turning beneath the clouds. You drift slowly upward again, rising from the imagined depths of Saturn's immense gaseous interior back toward the upper cloud tops. And as light gradually returns, you begin to sense how Saturn's atmosphere is not only shaped by heat and rotation, but also by subtle seasonal changes that unfold over decades. Saturn has seasons due to its axial tilt of about 26.7 degrees. This tilt is similar to Earth's, but Saturn's year is much longer. One orbit around the Sun takes Saturn about 29.5 Earth years. This means each season lasts more than 7 Earth years. You sense how sunlight shifts slowly across the hemispheres. For years at a time, one pole leans toward the sun, the other rests in shadow. Seasonal sunlight affects Saturn's atmospheric circulation. Temperature differences between hemispheres gradually change wind patterns. Cloud formations shift. Storm activity varies. You drift toward the North Pole once more. The hexagon remains steady, but its color changes with the seasons. The color of Saturn's north polar hexagon shifts with seasonal sunlight. At times it appears bluish, at others golden. Photochemical reactions in the upper atmosphere respond to changing light. Ultraviolet radiation alters Saturn's atmospheric chemistry. Methane and other hydrocarbons break apart. New molecules form. Haze thickens or thins. You begin to feel how Saturn's upper atmosphere is constantly being reshaped by sunlight interacting with gas. Invisible reactions, quiet chemistry, slow transformation. You drift across the equator again. Bands appear faint but structured. Saturn's banding is less pronounced than Jupiter's due to thicker haze layers. The haze softens contrasts, giving Saturn its calm, muted appearance. Yet beneath that calmness, winds still race at incredible speeds. You sense how Saturn radiates heat outward into space. Saturn emits roughly twice as much energy as it receives from the Sun. This internal heat likely comes from slow gravitational contraction. As Saturn gradually compresses under its own gravity, energy is released. Saturn slowly contracts over time, releasing gravitational energy. You begin to feel how Saturn's storms are not temporary disturbances. They are expressions of a long-term internal process. Heat rising, gas circulating, energy redistributing. And as you float gently above Saturn's glowing cloud tops, watching light fade into the curve of the horizon, you remain calm and weightless, aware that this giant world breathes in cycles of decades and centuries, shaped by seasons, chemistry, and internal heat that will continue to stir its atmosphere for billions of years. You drift slowly along the boundary where Saturn's golden atmosphere meets the vast darkness of space, allowing your awareness to settle into the full scale of this immense weather system. And you begin to sense how Saturn's storms are not isolated phenomena, but part of a planetary engine that has been running quietly for billions of years. Saturn's atmosphere extends thousands of kilometers above its deeper interior layers. There is no clear surface, no firm boundary, only increasing pressure and density as you descend. You sense how the planet's rapid rotation influences even its magnetic environment. Saturn's magnetic field is nearly perfectly aligned with its rotation axis. This alignment is unusual among planets. It creates a symmetrical magnetosphere, invisible, expansive, protective. You begin to feel how Saturn's upper atmosphere glows faintly at the poles. Saturn has auroras near its poles. These auroras form when charged particles from the solar wind interact with the magnetic field.
Energy travels along magnetic lines, colliding with atmospheric gases, producing light. Silent curtains of ultraviolet glow. You drift toward the night side of Saturn. Storm systems continue even without sunlight, because much of Saturn's energy comes from within. Internal heat drives Saturn's atmospheric circulation more than sunlight does. This makes Saturn fundamentally different from Earth. Its weather is not dependent on day and night alone. It is sustained from deep inside. You sense how storms rise from below, grow, spread, and fade, yet the overall circulation remains, a constant engine, layer upon layer of moving gas. You begin to feel how Saturn is not a static sphere of clouds, but a dynamic and evolving system where heat, rotation, chemistry, and magnetism are intertwined in endless motion. As you float quietly above this vast ocean of gas, watching faint auroras shimmer at the poles and distant lightning flicker beneath the clouds, you remain calm and weightless, aware that Saturn's storms are not chaotic accidents, but the visible heartbeat of a giant planet slowly releasing its internal energy into the dark expanse of space.
Part 5. The Interior of a Giant. You drift slowly inward again, letting Saturn's cloud tops dissolve beneath you as your awareness moves beyond storms and winds into the hidden layers below. And you begin to sense how this enormous planet is not hollow or empty, but structured in vast, compressed layers shaped by gravity and immense pressure. Saturn is classified as a gas giant, but that phrase can be misleading. Saturn is not simply a ball of gas floating loosely in space. It is a world where gravity compresses material into increasingly exotic states. Saturn's mass is about 95 times that of Earth. This immense mass pulls everything inward. Gas becomes denser. Pressure rises rapidly with depth. You descend in imagination through layers of hydrogen. At first, it is gaseous, light, expansive, but deeper down, molecules are squeezed tightly together. Hydrogen transitions from gas to liquid under high pressure inside Saturn. There is no sharp boundary, only gradual change. Gas becomes fluid. Fluid becomes metallic. You sense how extraordinary this transformation is. Deep inside Saturn, hydrogen likely exists in a metallic state. In this state, hydrogen conducts electricity. It behaves almost like molten metal. This metallic hydrogen layer is immense. It surrounds a deeper core. You begin to feel how Saturn's magnetic field is born here. Electrical currents within metallic hydrogen generate Saturn's magnetic field. This invisible field extends far into space, protecting the planet from solar wind, shaping charged particles. Beneath the metallic hydrogen lies something even more mysterious, a dense core. Saturn is believed to have a rocky and icy core. This core may be many times the mass of Earth, but it is not clearly defined. Recent research suggests something unusual. Saturn may have a fuzzy or diffuse core rather than a solid, compact one. Instead of a sharp boundary, heavy elements may gradually mix outward into the surrounding layers. You sense how Saturn is not layered like a simple onion. It may be blended, mixed, gradually transitioning from core to metallic hydrogen to liquid hydrogen to gaseous layers above. You begin to feel how Saturn radiates heat from its interior.
Saturn emits more energy than it receives from the Sun. This excess heat likely comes from slow gravitational contraction. As Saturn gradually compresses under its own gravity, energy is released, a slow and steady process, over billions of years. You drift calmly within this imagined descent, feeling how Saturn is not only defined by its rings or storms, but by its immense interior, where pressure transforms matter into states rarely found elsewhere, and where gravity quietly shapes a giant world layer by layer. And as you rise gently back toward the cloud tops in your awareness, you remain calm and weightless, aware that beneath Saturn's serene golden exterior lies a vast and powerful internal structure, hidden from sight, yet fundamental to everything the planet is.
You drift even deeper in imagination, allowing your awareness to settle into the immense pressures within Saturn's interior, and you begin to sense how extreme the conditions truly become as gravity compresses layer upon layer of hydrogen and helium beneath the visible clouds. Pressure inside Saturn increases to millions of times Earth's atmospheric pressure. Under such force, ordinary matter behaves in extraordinary ways. Hydrogen molecules are pushed so tightly together that their electrons begin to move freely. Metallic hydrogen inside Saturn conducts electricity. This electrically conductive layer is vast, stretching through a significant portion of the planet's interior. You sense how this layer is not calm or static. It slowly circulates, moving under the influence of heat and rotation. Convection occurs within Saturn's deep interior. Warm material rises, cooler material sinks. This slow churning motion, combined with rotation, generates magnetic fields. Saturn's magnetic field is generated by a dynamo effect. Unlike Earth, Saturn's magnetic field is almost perfectly aligned with its rotational axis. Saturn's magnetic field has an unusually low tilt relative to its axis. This symmetry makes it somewhat unique among planets. You begin to feel how Saturn's immense mass creates extraordinary gravitational force. Saturn's surface gravity is slightly stronger than Earth's, despite its low density. Because Saturn is so large, its gravity pulls strongly at its outer layers. Yet its low overall density keeps that pull from becoming overwhelming. You drift lower still in imagination toward the mysterious core. Saturn's core may be between 10 and 20 times the mass of Earth. This core likely contains rock, ice, and heavy elements, but it may not be sharply defined. Instead, heavy materials may gradually blend into surrounding layers. Saturn may have a partially mixed or diluted core structure. You sense how Saturn formed early in the solar system. Its core likely formed first. Saturn likely began as a solid core that attracted surrounding gas. Once it reached a critical mass, gas rapidly accumulated. Hydrogen and helium flooded inward. The planet expanded dramatically. You begin to feel how Saturn's interior still holds heat from that formation. Residual heat from billions of years ago, still radiating outward, still fueling convection. As you remain calm and weightless within this imagined descent, you sense that Saturn's interior is not a simple stack of layers, but a vast, slowly evolving structure shaped by gravity, pressure, and time, quietly maintaining the planet's magnetic field and internal heat as it drifts through the outer solar system. You drift gently within Saturn's immense interior once more, letting your awareness rest in the slow and powerful forces that shape this giant planet from within.
and you begin to sense how Saturn is not only held together by gravity, but also slowly transformed by it over unimaginable spans of time. Saturn continues to slowly contract under its own gravity. This contraction is subtle, measured in tiny amounts over millions of years, but it releases energy. Gravitational contraction generates internal heat. This process is known as the Kelvin-Helmholtz mechanism. It allows Saturn to glow faintly in infrared light. Saturn emits significant infrared radiation, more than it receives from the Sun. You sense how this internal heat source keeps the deep interior active, even after billions of years. Saturn is still thermally evolving today. You drift deeper in imagination toward regions where helium behaves differently. Something unusual happens in Saturn's interior. Helium may separate from hydrogen deep inside Saturn. Under extreme pressure and temperature, helium droplets can form. These droplets sink downward, like rain. Helium rain may occur inside Saturn. As helium falls toward the core, it releases additional heat. This may help explain Saturn's excess energy output. You begin to feel how Saturn's internal chemistry is not static. It changes with depth. It changes with time. You sense how the separation of elements slowly alters the planet's composition. Saturn's atmospheric helium content is lower than expected. This supports the idea that helium has migrated inward. You drift slowly upward again in awareness, toward the boundary between deep interior and upper atmosphere. Pressure decreases. Hydrogen transitions from metallic to liquid to gas, each layer blending into the next. There is no solid ground, no clear floor, only gradual change. You begin to feel how Saturn's interior is a place of continuous transformation, slow, silent, relentless. Gravity compresses, heat escapes, helium reigns, magnetic fields are sustained. And as you float calmly within this imagined journey through Saturn's depths, you remain weightless and peaceful, aware that beneath the planet's golden clouds lies an immense and evolving interior, shaped by gravity and time, quietly sustaining the giant world above. You drift slowly upward from Saturn's deep interior, allowing the immense pressures in metallic hydrogen seas to fade behind you. And as you return toward the upper layers of the planet, you begin to sense how everything visible above, the storms, the bands, the rings, even the magnetic field, is ultimately shaped by the quiet processes unfolding far below. Saturn's interior structure influences its atmospheric behavior. The heat rising from deep within fuels convection. Convection feeds jet streams shape storms. Everything is connected. You sense how Saturn's immense mass compresses its own core, and yet over billions of years, even a giant planet gradually changes. Saturn is slowly cooling over time. As heat escapes into space, the planet's internal energy reservoir decreases, but this process is extremely slow. Saturn will continue radiating heat for billions of years. You begin to feel how Saturn's internal evolution affects its future. As the planet cools further, convection may weaken, magnetic field strength may change, atmospheric circulation could gradually shift. Yet none of this will happen quickly. Saturn moves on timescales far beyond human life. You drift near the outer layers again, where hydrogen is still gaseous. Clouds swirl gently, storms roll across the atmosphere, all powered by the immense energy stored below. You sense how Saturn is not just a planet with rings, but a vast self-regulating system. Gravity compresses, heat rises, helium sinks, magnetism forms, energy radiates outward. Saturn's internal processes are driven by gravity and residual formation heat. Without gravity, there would be no compression. Without compression, no heat. Without heat, no storms. You begin to feel how Saturn's identity is deeply tied to its mass. Had it formed slightly larger, it might have ignited as a star. Had it formed smaller, it might never have gathered its massive atmosphere. Saturn is not massive enough to sustain nuclear fusion. It remains a planet, not a star, a giant, but a quiet one. As you float gently above Saturn's golden cloud tops once more, you remain calm and weightless, aware that beneath the serene surface lies an immense and evolving interior, a deep gravitational engine that has been slowly shaping this ringed giant since the dawn of the solar system, and will continue to do so long after the rings themselves have faded into darkness.
Part 6. The Magnetic Realm. You drift slowly outward from Saturn's cloud tops once more, leaving behind the golden storms and rising currents of gas. And as you move into the invisible space surrounding the planet, you begin to sense that Saturn's presence extends far beyond what the eye can see. There is a boundary here, an invisible shield, a region where charged particles are deflected and guided by unseen forces. Saturn has a vast magnetosphere. This magnetosphere is generated deep within the planet's interior. Electrical currents in metallic hydrogen create Saturn's magnetic field. The field stretches far into space, much farther than the visible rings. You drift toward the sunlit side of Saturn. Here, the solar wind presses against the magnetosphere. The solar wind is a stream of charged particles flowing from the sun. When this stream meets Saturn's magnetic field, it is deflected, compressed, redirected. Saturn's magnetosphere shields the planet from most solar wind particles, but not all. Some particles are captured, guided along magnetic field lines. You sense how these charged particles spiral toward the poles. Saturn has auroras at both poles. These auroras glow primarily in ultraviolet light, invisible to human eyes without instruments. They form when energetic particles collide with gases in Saturn's upper atmosphere, releasing light, silent curtains of energy. You drift around to the night side. The magnetosphere stretches into a long tail behind the planet. Saturn has a magnetotail extending millions of kilometers into space. This tail forms as solar wind pulls magnetic field lines outward. You begin to feel how Saturn's magnetic realm is not static. It fluctuates, responds to solar activity, expands and contracts. Saturn's magnetosphere changes in response to solar storms. When the sun becomes active, Saturn's magnetic boundary shifts, compressed by increased particle flow. You sense how Saturn's moons exist within this magnetic environment. Titan orbits inside the magnetosphere much of the time. Enceladus contributes material to it. Material from Enceladus feeds Saturn's magnetosphere. Water vapor from its plumes becomes ionized, captured by magnetic fields. You begin to feel how Saturn's magnetic realm is a complex ecosystem of charged particles, radiation, and invisible lines of force, shaping not only the space around the planet, but also influencing its rings and moons. As you float gently within this vast magnetic bubble, watching faint auroras shimmer at the poles and invisible currents ripple through space, you remain calm and weightless, aware that Saturn's true size extends far beyond its clouds, reaching outward into a dynamic and ever-shifting realm of magnetism and light.
You drift deeper into Saturn's invisible magnetic domain, allowing your awareness to follow the faint, curving lines of force that arc outward from the planet and stretch far into space. And you begin to sense how this magnetic field is not simply a protective bubble, but an active and dynamic environment filled with motion and energy. Saturn's magnetosphere is the second largest in the solar system after Jupiter's. It extends millions of kilometers into space, forming a vast cavity within the solar wind. On the sunward side, the magnetosphere is compressed. On the night side, it stretches into a long magnetic tail. Saturn's magnetotail can extend more than 1 million kilometers behind the planet. Within this space, charged particles become trapped,
They spiral along magnetic field lines. They bounce between the poles. Saturn has radiation belts composed of trapped charged particles. These belts are not as intense as Jupiter's, but they are significant. You sense how particles come from multiple sources. Some originate from the solar wind. Some are supplied by Saturn's moons. Enceladus is a major source of plasma within Saturn's magnetosphere. Water vapor from its geysers becomes ionized. These ions are then captured by magnetic fields, carried around the planet. You drift toward Titan's orbit. Sometimes Titan moves inside Saturn's magnetosphere. Other times, it briefly passes through the solar wind. Titan's orbit occasionally carries it outside Saturn's magnetosphere. When this happens, Titan experiences direct interaction with solar particles. Its thick atmosphere shields its surface, but its upper layers respond to this exposure. You begin to feel how Saturn's magnetic field rotates along with the planet. Saturn's magnetic field rotates with the planet's interior, yet measuring its exact rotation rate is surprisingly difficult. Unlike Jupiter, Saturn's magnetic field is nearly symmetrical. Saturn's magnetic axis is almost perfectly aligned with its rotational axis. This alignment makes it challenging to determine the planet's true internal rotation speed. You sense how even in invisibility, structure exists. Currents flow, particles accelerate, auroras brighten and fade. Magnetic reconnection events occur. Magnetic reconnection releases bursts of energy within Saturn's magnetosphere. These events can accelerate particles and intensify auroras. You begin to feel how Saturn's magnetic realm is not silent. It hums with motion, invisible storms, electrical currents, radiation belts circling in steady rhythm. And as you remain calm and weightless within this vast magnetic environment, you sense that Saturn's influence extends far beyond its rings and clouds, shaping a hidden world of charged particles and shifting energy that surrounds the giant planet in a dynamic and ever-changing embrace.
You drift slowly along the boundary where Saturn's magnetosphere meets the streaming solar wind, allowing your awareness to settle into the delicate tension between planetary force and stellar pressure. And you begin to sense how this invisible frontier constantly shifts, responding to changes in the sun's activity. Saturn's magnetosphere expands and contracts depending on solar wind pressure. When solar wind strengthens, the magnetic boundary is pushed inward. When solar activity weakens, the magnetosphere expands outward. This quiet breathing continues endlessly. You sense how magnetic field lines on the sunlit side are compressed tightly. On the night side, they stretch far into space. Saturn's magnetotail stores energy in stretched magnetic field lines. Occasionally, these lines snap and reconnect. Magnetic reconnection in Saturn's magnetotail releases bursts of energy. These bursts accelerate charged particles. They send waves of energy toward the poles. Auroras brighten, then fade. You drift toward the poles once more. Faint curtains of ultraviolet light shimmer, invisible to human eyes without instruments. Saturn's auroras are strongest in ultraviolet wavelengths. They form when energetic electrons collide with hydrogen in the upper atmosphere. Unlike Earth's colorful auroras, Saturn's glow is more subtle, more distant. You begin to feel how Saturn's magnetic field also influences its rings. Charged ring particles respond to magnetic forces. Electromagnetic interactions can affect fine dust within Saturn's rings.
This may explain transient features such as spokes. You sense how the magnetosphere also interacts with Saturn's atmosphere. Particles entering near the poles can alter chemical reactions. Charged particles can modify Saturn's upper atmospheric chemistry. This invisible exchange slowly reshapes the composition of gases at high altitudes. You drift outward slightly, looking back at the entire system. Planet, rings, moons, magnetic field extending beyond all of them. You begin to feel how Saturn is not just a physical object, but a complex electromagnetic system interacting continuously with the Sun and with its own moons. Nothing is isolated. Solar wind flows, magnetic fields respond, moons supply material, auroras glow, and as you remain calm and weightless within this vast magnetic frontier, you sense that Saturn's invisible realm is as intricate and dynamic as the rings that shimmer in sunlight. A hidden structure of energy quietly shaping the space around the ringed giant.
You drift gently along the outer boundary of Saturn's magnetosphere, allowing the immense planet to rest behind you while its invisible magnetic influence stretches outward into space, and you begin to sense how this unseen structure is not permanent or rigid, but constantly shaped by the rhythm of the Sun and the slow rotation of the giant world itself. Saturn's magnetosphere rotates along with the planet. As Saturn spins, its magnetic field carries plasma with it. This rotation creates currents within the magnetosphere. Rotational energy powers much of Saturn's magnetospheric dynamics. Unlike Earth, where solar wind plays the dominant role, Saturn's rapid rotation significantly influences its magnetic environment. You sense how plasma originating from Enceladus becomes trapped and carried around the planet. Enceladus supplies water-derived plasma to Saturn's magnetosphere. This plasma forms a torus, a donut-shaped region of charged particles encircling Saturn. Saturn has a plasma torus associated with Enceladus. Over time, this plasma spreads outward. Some escapes down the magnetotail, some falls inward along magnetic field lines. You begin to feel how energy constantly flows through this system. Nothing stands still. Charged particles accelerate, magnetic lines stretch and reconnect. Auroras brighten, fade, return again. Saturn's auroral activity varies with both solar wind and internal rotation. This means the light at its poles responds to forces both external and internal, a dialogue between star and planet. You drift slowly outward once more, seeing Saturn's magnetosphere as a vast bubble embedded within the heliosphere of the Sun. Saturn's magnetosphere acts as a protective shield for its rings and inner moons. Without it, solar wind would more directly erode fine particles and alter atmospheric chemistry on moons like Titan. You begin to feel how Saturn's magnetic realm adds another invisible layer to its identity. Clouds form its visible skin, rings form its luminous crown, moons form its family, and magnetism forms its unseen aura. As you remain calm and weightless at the edge of this magnetic boundary, you sense that Saturn's true size cannot be measured only by its physical diameter, but by the reach of its invisible influence stretching far into space, shaping particles and light long before they ever touch the planet's golden clouds.
Part 7: Saturn and Time. You drift slowly outward along Saturn's orbit, allowing the planet to move gently through the vast darkness around the Sun, and you begin to sense how differently time flows here, far from Earth.
where seasons last for years and decades pass like quiet chapters in a much longer cosmic story. 1 year on Saturn lasts about 295 Earth years. This means Saturn takes nearly 3 decades to complete a single orbit around the Sun. While Earth experiences 4 seasons in 1 year, Saturn's seasons stretch across many human lifetimes. Each season on Saturn lasts more than 7 Earth years. You sense how sunlight shifts slowly across the hemispheres. For years at a time, one pole leans toward the Sun, the other remains in prolonged shadow. Storm patterns change gradually. Atmospheric colors shift subtly. You drift toward the rings and notice how their angle changes over time. Saturn's rings tilt at about 27 degrees relative to its orbital plane. As Saturn moves along its orbit, this tilt changes how the rings are illuminated. Sometimes they appear wide and brilliant from Earth. Other times they become thin and nearly invisible. Every 15 years, Saturn's rings appear edge-on from Earth. During these moments, the magnificent ring system seems to disappear. A reminder that perspective shapes what we see. You begin to feel how Saturn's rotation differs dramatically from its revolution. 1 day on Saturn lasts about 7 Earth hours. Despite its enormous size, Saturn spins rapidly. Cloud bands whip around the planet. Storm systems rotate swiftly. Yet its orbit around the Sun is slow and patient. Fast rotation, slow revolution, 2 rhythms intertwined. You drift back in time in imagination toward Saturn's formation. Saturn formed around 4-5 billion years ago. Since then it has circled the Sun hundreds of millions of times, each orbit nearly 30 Earth years long. You sense how Saturn has watched the solar system change. Asteroids collide, comets pass, moons evolve, rings form and slowly thin. And through it all, Saturn continues its quiet journey. You begin to feel how human history is only a fleeting moment in Saturn's long year. Entire civilizations rise and fall during a single Saturnian season. Yet Saturn's path remains steady, predictable, precise. As you float gently beside this ringed giant, watching it move slowly along its vast orbit, you remain calm and weightless, aware that Saturn's sense of time is measured not in days or decades, but in epochs, a giant world patiently circling its star across billions of years of silent cosmic history. You drift gently along Saturn's orbit, allowing your awareness to stretch across decades and centuries, and you begin to sense how the slow passage of time shapes not only the planet's seasons, but also its rings, its moons, and even its internal evolution. Saturn's axial tilt is about 26.7 degrees. This tilt creates long, gradual seasonal changes across its hemispheres. When the northern hemisphere tilts toward the Sun, sunlight warms its upper atmosphere for years. The cloud chemistry shifts. Haze layers thicken or thin. Storm activity changes subtly. Seasonal sunlight alters Saturn's atmospheric color and temperature. You sense how these changes unfold slowly, almost imperceptibly from one Earth year to the next. Only over decades does the transformation become clear. You drift toward the poles again. During winter, one pole remains in darkness for many Earth years. Saturn's polar regions experience extended periods of darkness. Then slowly sunlight returns, auroras glow differently, cloud patterns reorganize, the hexagon shifts in hue. Time here is patient, expansive, unhurried. You begin to feel how Saturn's rings are also shaped by time. Saturn's rings are gradually evolving. Collisions between particles slowly grind ice into smaller fragments. Micrometeoroid impacts darken the once pure ice. Ring particles become darker over time due to space weathering, material spirals inward. Ring rain slowly feeds Saturn's upper atmosphere. This process is not dramatic, not visible in a single lifetime, but measurable across millions of years. You sense how Saturn's moons also change with time. Tidal forces slowly alter the orbits of Saturn's moons. Some moons are gradually moving farther away from the planet, ever so slightly, centimeter by centimeter each year. Over billions of years, these distances grow significant. You drift back toward Titan. Methane clouds gather, rain falls, lakes fill and evaporate. Titan's methane cycle operates on seasonal timescales. Even this alien weather system follows Saturn's long orbital rhythm. You begin to feel how Saturn exists in layers of time, rapid rotation in hours, storm cycles in years, seasons in decades, orbital shifts in millions of years, ring evolution in hundreds of millions, planetary cooling in billions, all happening simultaneously, all interwoven. As you float calmly beside this vast and patient world, you remain weightless and peaceful, aware that Saturn moves through time in grand, overlapping cycles, a planet whose rhythms extend far beyond human memory, quietly evolving as it circles the sun in slow, majestic continuity. You drift slowly farther along Saturn's immense orbit, letting your awareness expand beyond individual seasons and into geological timescales, and you begin to sense how this ring giant has witnessed nearly the entire history of the solar system unfold. Saturn has completed over 150 million orbits around the Sun since its formation, each orbit lasting nearly 30 Earth years, each one carrying the planet steadily through space. You sense how Saturn's rings have not always looked the way they do now. Saturn's rings may be relatively young compared to the planet itself, perhaps formed from a shattered moon, perhaps from captured icy debris, but temporary on cosmic timescales. You begin to feel how time slowly erodes brilliance. Micrometeorites strike the rings. Tiny impacts darken the ice. Without renewal, Saturn's rings would gradually become darker over time. This suggests that the rings may be replenished, or that they formed more recently. You drift toward the inner moons. Tidal forces between Saturn and its moons generate internal heat. This heat drives activity on moons like Enceladus. Over time, tidal interactions slowly change orbital distances. Saturn's tidal forces cause some moons to migrate outward. This outward drift happens slowly, measured in centimeters per year. But over billions of years, those centimeters become thousands of kilometers. You sense how Saturn itself is evolving. Saturn is slowly cooling as it radiates internal heat into space. As it cools, its interior structure subtly shifts. Helium continues to rain downward. Metallic hydrogen layers gradually adjust. You begin to feel how Saturn's magnetic field may also evolve with time. Changes in internal convection could alter Saturn's magnetic field over billions of years. Nothing dramatic, nothing sudden, just slow transformation. You drift outward in imagination, looking back at Saturn from afar, rings glowing faintly, moons tracing quiet paths, auroras shimmering at the poles, storms rolling across the clouds. And you begin to feel how Saturn's timeline stretches both backward and forward, billions of years into the past and billions into the future. A world that formed in the earliest days of the solar system and will continue its silent orbit long after Earth itself has changed beyond recognition. As you remain calm and weightless beside this ancient giant, you sense that Saturn is not defined by a single moment in time, but by an ongoing journey through cosmic history, shaped slowly and patiently by gravity, motion, and the steady passage of billions of years. You drift gently into a broader awareness of time itself, letting Saturn continue its slow journey around the Sun, while you imagine what the distant future may hold for this ringed giant. And you begin to sense how even something as immense and seemingly eternal as Saturn is only temporary within the greater lifespan of the cosmos. The Sun will eventually evolve into a red giant in about 5 billion years. When that happens, the inner solar system will change dramatically. Mercury and Venus may be engulfed. Earth may be transformed beyond recognition. But Saturn lies far enough away that it may survive the Sun's expansion. Saturn is far enough from the Sun to likely avoid being swallowed during the red giant phase, yet its environment will not remain unchanged. The Sun's increased luminosity will warm the outer solar system. Saturn's upper atmosphere may heat. Its moons may experience rising temperatures. Ice may sublimate more rapidly. You sense how even the rings would be affected. Increased solar radiation could alter their structure. Material may disperse more quickly. Saturn's rings are unlikely to survive indefinitely. Long before the Sun transforms, the rings may fade. Ring rain will continue. Particles will spiral inward. Some may coalesce into small moons. Some will be lost to the planet. You begin to feel how Saturn itself will slowly cool. Over billions of years, Saturn will gradually lose its internal heat. Convection may weaken. Storm intensity could diminish. The planet may become quieter, colder, more subdued. Yet it will continue to orbit, steady, predictable. You drift outward further, imagining the distant era when the Sun sheds its outer layers and becomes a white dwarf. Saturn may still remain, a colder giant, orbiting a dim stellar remnant. Saturn may survive into the white dwarf stage of the Sun's life, its rings likely gone, its atmosphere altered, but its mass and structure largely intact. You begin to feel how Saturn's existence stretches across almost the entire life cycle of its star, from formation in a young protoplanetary disk, through billions of years of stable orbit, into the distant twilight of stellar evolution. As you float quietly beside this ancient giant, watching its rings glow softly against the dark, you remain calm and weightless, aware that Saturn's story is not fixed in the present moment, but unfolds across billions of years, a slow and majestic journey through cosmic time that will continue long after the current age of the solar system has faded into memory. Part 8: Exploration and Discovery. You drift gently closer to Saturn once more, but this time your awareness shifts from the planet itself to the small, fragile machines that humanity has sent across billions of kilometers of space to study this distant giant. And you begin to sense how Saturn was once only a faint point of light, mysterious and unreachable, until curiosity carried instruments into its realm. Saturn has been observed by humans for thousands of years. Ancient astronomers saw it move slowly against the background stars. Because of its slow motion, it was named after the Roman god of time. Saturn is visible to the naked eye from Earth, but for centuries, its rings remained hidden. It was only in the 17th century that something extraordinary was noticed. Galileo Galilei first observed Saturn's rings in 1610. However, his telescope was too small to clearly resolve them. He described Saturn as having ears or handles. Later, stronger telescopes revealed the truth. Christian Huygens correctly identified Saturn's rings in 1655. You sense how Saturn remained distant and mysterious for centuries. A beautiful object in the night sky, but still largely unknown. That changed in the 20th century. Pioneer 11 was the first spacecraft to fly past Saturn in 1979. It provided the first close-up images, revealing more detail than ever before. Then came a more detailed mission. Voyager 1 and Voyager 2 flew past Saturn in 1980 and 1981. They discovered new moons, studied the rings, captured breathtaking images. But the most transformative mission was yet to come. You drift forward in time to the early 21st century. A spacecraft entered orbit around Saturn. The Cassini spacecraft orbited Saturn from 2004 to 2017. For over a decade, Cassini studied the planet in unprecedented detail. It mapped the rings, explored the magnetosphere, discovered geysers on Enceladus. Cassini confirmed active plumes on Enceladus. It also released a probe toward Titan. The Huygens probe landed on Titan in 2005. It transmitted images from the surface, revealing river channels and icy terrain. For the first time, humanity saw the surface of a moon in the outer solar system. You sense how Cassini ended its mission dramatically. Cassini performed a controlled dive into Saturn's atmosphere in 2017. This prevented contamination of moons like Enceladus. The spacecraft burned up in the atmosphere, becoming part of the planet it studied. You drift quietly, feeling how Saturn is no longer only a distant light in the sky. It is mapped, measured, explored, yet still mysterious. As you remain calm and weightless beside this ringed giant, you sense that human exploration has only begun to uncover Saturn's secrets, and that even after decades of study, this vast and beautiful world continues to invite curiosity and quiet wonder. You drift gently through the quiet legacy of Saturn's exploration, letting the memory of spacecraft glide through your awareness, and you begin to sense how each mission did not merely pass by the planet, but transformed our understanding of the entire outer solar system. Voyager 1 discovered that Titan has a thick, opaque atmosphere. Before Voyager, Titan was little more than a blurred orange sphere. Afterward, it became a world of intrigue. Voyager 2 revealed complex structures within Saturn's rings. It identified gaps, ringlets, and gravitational interactions in far greater detail. These early flybys hinted that Saturn's system was far more complex than imagined. But it was Cassini that changed everything. Cassini completed nearly 300 orbits of Saturn. Over 13 years, it passed close to many moons, studied storms, dove between the rings and the planet. Cassini performed daring grand finale orbits between Saturn and its rings. During these final passes, it measured Saturn's gravity and magnetic field with unprecedented precision. You sense how Cassini discovered entire new phenomena. Cassini detected a global ocean beneath Enceladus's icy crust. By measuring tiny gravitational variations, it confirmed liquid water below the surface. This discovery reshaped the search for life. Enceladus is now considered one of the most promising places to search for extraterrestrial life. You drift toward Titan once more. Cassini mapped its surface using radar. Cassini discovered lakes and seas of liquid methane on Titan. It revealed shorelines, river channels, dune fields made of organic particles. Then came the Huygens probe. Huygens remains the only probe to land in the outer solar system. It descended through Titan's atmosphere for over 2 hours, transmitting data and images. Its landing site showed pebbles rounded by liquid flow, evidence of methane rivers. You begin to feel how exploration is layered, each mission building on the last, each discovery raising new questions. Cassini discovered 6 new moons around Saturn. It also measured the thickness and mass of the rings more accurately than ever before. You sense how even after Cassini's end, Saturn remains a target for future exploration. Future missions may return to study Titan and Enceladus in greater detail. Plans exist to send drones to Titan, landers to Enceladus. You drift quietly, feeling how human curiosity has reached across nearly 15 billion kilometers to touch this distant giant. And yet so much remains unknown. As you remain calm and weightless beside Saturn, you sense that exploration has transformed it from a distant point of light into a richly detailed world of storms, oceans, rings, and magnetic fields, but that its mysteries are far from exhausted, quietly waiting for the next generation of explorers to continue the journey. You drift gently forward in time, beyond the era of Cassini, and you begin to sense how Saturn continues to inspire future missions and new technological dreams, as humanity looks outward once more toward the ringed giant and its remarkable moons. NASA's Dragonfly mission is planned to explore Titan. Unlike previous spacecraft, Dragonfly will not simply orbit or land once. It will fly. Dragonfly will be a rotorcraft drone designed to hop across Titan's surface. Titan's thick atmosphere and low gravity make flight possible. It will explore dunes, icy plains, and possibly the edges of methane seas. Dragonfly is scheduled to launch in the mid-2020s. Its goal is not only to study geology but chemistry, to search for complex organic molecules, to understand prebiotic processes. You sense how Saturn's system has become central to the search for life beyond Earth. Enceladus's subsurface ocean may contain hydrothermal activity. Cassini detected tiny grains of silica in its plumes. These grains suggest interaction between water and warm rock. Hydrothermal reactions on Enceladus may resemble those on Earth's ocean floors. On Earth, such environments support life. You drift quietly, imagining future missions sampling plume material directly, flying through geysers, collecting particles, analyzing them for biological signatures. Future missions may directly sample Enceladus's plumes for biosignatures. You sense how Saturn is no longer only a destination for observation. It is a destination for investigation, for chemistry, for astrobiology. You drift outward, imagining advanced telescopes studying Saturn from afar. Modern space telescopes continue to observe Saturn in infrared and ultraviolet wavelengths. Even from millions of kilometers away, data continues to flow. Storm systems are tracked, seasonal changes recorded, ring structures monitored. You begin to feel how exploration never truly ends. Even when a spacecraft burns in Saturn's atmosphere, its data remains, its discoveries endure. You sense how Saturn represents one of humanity's most successful deep space endeavors. From Galileo's blurred observations, to Cassini's detailed maps, to Dragonfly's future flights. As you remain calm and weightless beside the ringed giant, you feel how Saturn has transformed from a distant, mysterious light into a living laboratory for science and discovery, and how its story continues to unfold, not only in the planet itself, but in the quiet determination of those who continue to explore it from across the vast darkness of space. You drift slowly into a quiet reflection on what exploration truly means, allowing Saturn's rings to shimmer faintly in the distance while you consider how far human curiosity has traveled. And you begin to sense that the story of Saturn is not only about storms and rings, but about the deep human desire to understand what lies beyond our world. Saturn is nearly 14 billion kilometers away from the Sun, and yet spacecraft built by human hands have reached it. Traveled for years through cold and darkness, carried instruments across the vast silence of space, you sense how communication with Saturn is delayed by distance. Radio signals from Saturn take about 80 minutes to reach Earth. Every command sent, every image received, is separated by time, a quiet reminder of scale. You drift through memory once more, Cassini sending back high-resolution images of the rings, mapping gravitational fields, measuring magnetic fluctuations. Cassini transmitted hundreds of gigabytes of scientific data, each byte revealing new details, each measurement refining models, each discovery expanding understanding. You begin to feel how exploration of Saturn has influenced broader science. Understanding gas giants helps explain exoplanets. Studying Saturn improves our understanding of giant exoplanets. Many planets discovered around other stars resemble Saturn in size and composition. By understanding Saturn, we understand countless distant worlds. You sense how exploration also changes perspective. Saturn's rings appear vast, yet from far away they are almost invisible. Humanity appears small, yet its reach extends across the solar system. You drift outward one last time, seeing Saturn as a luminous sphere wrapped in ice, orbiting quietly in the dark, while tiny machines from a small blue planet have touched its realm. You begin to feel how exploration is not about conquest, not about possession, but about understanding, curiosity crossing distance, knowledge growing slowly. As you remain calm and weightless beside the ringed giant, you sense that Saturn's exploration is still unfinished, that future missions will return, new instruments will listen, new questions will arise, and that this distant world will continue to inspire wonder and discovery for generations yet to come, quietly waiting in the outer solar system beneath its shimmering crown of ice. Part 9: Saturn's place in the solar system. You drift slowly outward from Saturn once more, allowing the rings to grow smaller behind you, and you begin to sense how this giant planet is not isolated, but plays an essential role within the larger architecture of the solar system. Saturn is not merely a beautiful object with rings, it is a gravitational anchor, a sculptor of orbits, a guardian of balance. Saturn is the second largest planet in the solar system. Its immense mass gives it influence far beyond its visible size. Saturn contains about 30% of the mass of Jupiter. Though smaller than Jupiter, it still exerts tremendous gravitational force. You sense how Saturn helps shape the outer solar system. Saturn's gravity influences the asteroid belt and outer debris populations. Over billions of years, its pull has altered countless trajectories. Some objects were ejected from the solar system, some redirected inward, some captured as moons. You begin to feel how Saturn works in partnership with Jupiter. Jupiter and Saturn together dominate the gravitational dynamics of the solar system. Their combined influence stabilizes planetary orbits, prevents excessive chaos. Models suggest something even more dramatic occurred long ago. Early migration of Jupiter and Saturn may have reshaped the solar system. The so-called NICE model proposes that these giants once shifted positions. Their movement scattered icy bodies, triggered impacts, possibly contributed to the late heavy bombardment. You sense how Saturn may have indirectly influenced Earth's history. By redirecting comets, by shaping asteroid paths, by stabilizing long-term orbital patterns, gas giants like Saturn help stabilize interplanetary orbits. Without them, the solar system might look very different. You drift farther outward, beyond Saturn's orbit, toward Uranus and Neptune. You begin to feel how Saturn acts as a bridge between inner rocky planets and distant icy worlds. Saturn marks the transition between the inner and outer solar system. Inside its orbit, planets are small and rocky. Beyond it, icy giants dominate. You sense how Saturn also influences smaller objects. Comets passing nearby can be redirected, captured temporarily, or flung outward into deep space. Saturn can gravitationally redirect comets and small bodies. You drift quietly, feeling how Saturn's role is not passive, it is active, shaping structure, maintaining balance, quietly guiding motion through gravity alone. As you remain calm and weightless in the vast space beyond its orbit, looking back at the ringed giant glowing softly against the dark, you sense that Saturn is more than a beautiful world, more than storms and rings and moons, but a fundamental pillar of the solar system's architecture, silently influencing the motion of countless objects as it continues its slow and majestic path around the Sun. You drift gently through the outer reaches of Saturn's orbit, letting your awareness widen to include the broader gravitational web of the solar system, and you begin to sense how Saturn does not simply exist within this structure, but actively shapes it through its immense and persistent gravitational influence. Saturn's gravitational field extends far beyond its rings and moons. Even distant objects feel its pull. Small icy bodies in the outer solar system have had their paths altered over billions of years. Saturn helps shape the distribution of objects in the Kuiper belt. Through slow gravitational nudges, Saturn and Jupiter together sculpt the architecture of distant debris. You sense how the gas giants act almost like cosmic gatekeepers. Gas giants can either protect or destabilize inner planets depending on orbital alignment. Some models suggest Saturn may have reduced the number of catastrophic impacts on Earth. Other models suggest it may have redirected icy bodies inward, both protective, both dangerous. You drift inward slightly, sensing how Saturn's gravity interacts with Jupiter's in a delicate balance. Jupiter and Saturn are near a 5:2 orbital resonance. This resonance means that for roughly every 5 orbits of Jupiter, Saturn completes about 2. Such gravitational relationships shape long-term orbital stability. You begin to feel how even slight shifts in Saturn's orbit in the distant past could have caused dramatic changes. Planetary migration likely occurred early in the solar system's history. Saturn may have moved inward and outward before settling into its current orbit. This movement would have scattered countless icy bodies, possibly delivering water to the inner planets. You sense how Saturn's mass also influences space debris. Saturn can capture passing objects into temporary orbit. Some irregular moons are likely captured remnants of distant icy bodies. Their strange, inclined, and retrograde orbits reveal their foreign origins. You drift outward again, imagining Saturn as part of a grand gravitational dance. Not stationary, not isolated, but constantly interacting. Every planet's orbit is influenced by every other, but Saturn's mass gives it a strong voice in this conversation. You begin to feel how Saturn represents a stabilizing giant. a massive presence that contributes to the long-term balance of planetary motion. Without it, orbital chaos might slowly increase over billions of years. As you remain calm and weightless in this expanded awareness of gravitational architecture, you sense that Saturn's importance lies not only in its rings or moons, but in its quiet and constant influence on the structure and stability of the entire solar system, shaping motion across billions of kilometers with nothing more than gravity and time. You drift even farther outward now, allowing Saturn to become one glowing presence among many in the vast architecture of the solar system, and you begin to sense how its role is not only gravitational, but structural, acting as one of the great pillars that define the system's overall balance. Saturn contains about 568 times the volume of Earth. Its enormous size means its gravitational reach influences regions far beyond its visible boundaries. Over billions of years, that influence has helped define the orbital spacing of the outer planets. The spacing of the giant planets contributes to long-term orbital stability. If Saturn were significantly closer to Jupiter, their gravitational interactions might destabilize the system. If it were much farther away, outer regions might look very different. You sense how Saturn also contributes to the shaping of resonant populations. Saturn helps maintain orbital resonances among smaller bodies. Some distant objects orbit the Sun in patterns locked into gravitational rhythms influenced by Saturn and Jupiter. These resonances prevent chaotic crossing of planetary paths. You drift slightly inward again and imagine the early solar system. Young, crowded, chaotic. Gas giants still forming. Gas giants likely influenced the final configuration of rocky planets. Their gravitational presence may have limited the mass available in the asteroid belt. They may have influenced how material accumulated closer to the Sun. You begin to feel how Saturn's existence may have indirectly shaped Earth's conditions, by affecting impact rates, by influencing delivery of volatile compounds, by stabilizing long-term orbital cycles. The gravitational architecture of the solar system influences planetary habitability. Saturn is part of that architecture. You sense how Saturn also contributes to the overall angular momentum distribution of the solar system. Gas giants contain most of the planetary mass in the solar system. While the Sun holds nearly all the mass, Saturn and Jupiter together dominate the planetary portion. This distribution affects how energy and momentum are balanced. You drift outward once more, seeing Saturn in its broader context, not isolated, not decorative, but integral, a structural giant. Holding position between Jupiter and Uranus, balancing forces, guiding motion, quietly maintaining order across billions of kilometers. As you remain calm and weightless in this expanded cosmic perspective, you sense that Saturn is not simply a planet with rings, but a fundamental component of the solar system's long-term stability, a massive presence whose gravitational voice continues to shape planetary motion across billions of years of silent cosmic time. You drift slowly into a wider and quieter perspective, allowing Saturn to settle into its proper place among the other planets, and you begin to sense how its existence is not accidental, but part of a delicate balance that allows the solar system to remain structured rather than chaotic. Saturn orbits the Sun at an average distance of about 9.5 astronomical units. This distance places it far beyond the asteroid belt, yet still well inside the realm of the icy giants. Its position is not random. It lies where temperature during formation allowed hydrogen and helium to accumulate efficiently. Saturn formed beyond the frost line of the early solar system. Beyond this boundary, ices could condense, allowing the rapid growth of a massive core. Without that distance, Saturn might never have become a gas giant. You sense how Saturn's mass contributes to a gravitational buffer zone. Saturn helps limit excessive orbital chaos among outer solar system bodies. Its presence prevents some smaller objects from wandering inward unpredictably, yet it can also send others outward into deep space. A quiet gatekeeper, balancing influence. You begin to feel how Saturn's existence may have influenced the overall symmetry of the planetary system. If Saturn were absent, Jupiter's dominance would be even greater. If Saturn were larger, orbital resonances might destabilize inner regions. The current configuration of Jupiter and Saturn contributes to long-term orbital stability. This configuration has persisted for billions of years. You drift outward in imagination, looking at the solar system as a whole. 4 rocky inner planets, asteroid belt, 2 gas giants, 2 ice giants, Kuiper belt beyond. Saturn sits near the center of this structure, a massive divider, a gravitational sculptor. You sense how even slight differences in Saturn's mass or orbit could have reshaped planetary history. Planets might have migrated differently. Impact histories might have changed. The architecture itself might not look the same. Small variations in giant planet orbits can dramatically alter planetary system outcomes. Saturn's present position represents one stable solution among many possible ones. As you float calmly in this broader cosmic view, watching Saturn continue its steady orbit, you remain weightless and peaceful, aware that the ringed giant is not merely a beautiful feature of the night sky, but a crucial component of the solar system's structure, quietly maintaining balance across vast distances through nothing more than gravity and time. Part 10: The Silent Giant. You drift slowly back toward Saturn one final time, allowing the vast architecture of the solar system to fade behind you. And as the ring giant fills your awareness once more, you begin to sense how everything you have explored, the rings, the storms, the moons, the magnetic realm, the slow march of time, comes together in this quiet and luminous world orbiting far from the sun. Saturn does not glow like a star. It does not blaze with fusion. It reflects light, softly, golden. Saturn reflects sunlight rather than producing its own light. Yet in its reflection, it reveals complexity, layer upon layer of structure. You sense how Saturn's rings shimmer faintly, billions of icy fragments orbiting in delicate balance. Saturn's rings contain billions of individual particles, each one following precise gravitational paths, each one slowly evolving. You drift across the cloud tops once more. Storms churn beneath soft haze. Lightning flashes deep below. The hexagon turns patiently at the pole. Saturn's north polar hexagon has persisted for decades, a reminder that even in turbulence, structure can emerge. You sense how Saturn's moons continue their endless orbits, Titan with its methane seas, Enceladus with its hidden ocean, Rhea, Iapetus, Dione, each following gravitational rhythms. Saturn's moon system is one of the most diverse in the solar system. Together, they form a miniature planetary system of their own. You begin to feel how Saturn's interior still radiates heat. Helium rains downward. Metallic hydrogen churns slowly. Magnetic fields stretch outward. Saturn emits more energy than it receives from the sun, a quiet internal engine sustaining its atmosphere. You drift outward slightly, seeing Saturn as a whole, a giant of hydrogen and helium, massive yet low in density. Saturn is the least dense planet in the solar system, a paradox, enormous, yet light, powerful, yet serene. You sense how Saturn's future will unfold slowly. Its rings may fade, its storms may weaken. Its orbit will continue long after human civilizations have changed beyond recognition. Saturn will continue orbiting the Sun for billions of years. And even when the Sun transforms, Saturn may remain altered but present. You drift quietly in the darkness beside this ringed giant, feeling the immense calm of a planet that moves without hurry, rotates without pause, and carries within its storms, oceans, rings, and magnetic realms, all bound together by gravity and time. And as you remain calm and weightless, watching Saturn's luminous rings glow softly against the endless black of space, you sense that this silent giant is not merely a distant planet, but a symbol of patience, balance, and quiet cosmic beauty, endlessly circling its star beneath a crown of ice that shines gently in the dark. You drift a little farther away from Saturn now, allowing its full silhouette to rest against the deep black of space, and you begin to sense how even in silence, this immense world carries a quiet presence that feels almost timeless. Saturn's equatorial diameter is about 120,500 kilometers. It is vast beyond ordinary imagination, and yet from Earth it appears as nothing more than a bright point of light. You sense how perspective shapes understanding. Up close, Saturn is layered with storms, rings, and moons. From afar, it is calm, steady, unmoving against the stars. Saturn is visible to the naked eye from Earth. For thousands of years, humans watched it wander slowly across the night sky. They did not know about rings or moons or hexagonal storms, yet it was always there. You drift gently along the edge of the rings again. Light scatters softly across ice. Shadows fall across cloud tops. Saturn's rings cast shadows onto the planet's atmosphere. During certain seasons, the planet casts shadows back onto the rings, a silent exchange of light and darkness. You sense how Saturn teaches scale of size, scale of time, scale of distance. Radio signals take over an hour to travel between Saturn and Earth. Storms last longer than human lifetimes. The seasons stretch across decades. You begin to feel how Saturn represents stability in motion. It rotates rapidly, yet orbits slowly. Its rings shift gradually, yet maintain structure. Its moons migrate outward, yet remain bound. Saturn's gravitational influence keeps its vast system in long-term balance. Nothing here feels rushed. Everything unfolds at planetary speed. You drift outward once more, letting Saturn become smaller again. A golden sphere, encircled by a thin, luminous line. Still, silent, yet alive with motion. And as you remain calm and weightless in the vast darkness, you sense that Saturn's beauty lies not only in its rings, but in its endurance, in its quiet persistence across billions of years, a giant world moving patiently through space, reminding you that even in the immense scale of the cosmos, balance and harmony can exist in steady and silent motion. You drift even farther into the quiet darkness now, letting Saturn shrink into a softly glowing jewel suspended in blackness, and you begin to sense how distance changes perception, how something so vast and complex can appear almost delicate when seen from far enough away. Saturn's average distance from Earth is over 1-2 billion kilometers. Across that immense gap, light travels for more than an hour before reaching human eyes. And yet, despite the distance, its presence is unmistakable. You sense how Saturn has become a symbol in human imagination. A ringed world, distinct, recognizable. Saturn is the only planet whose ring system is easily visible through small telescopes. For many, it is the first planet observed with detail. The first glimpse of another world that feels undeniably different from Earth. You drift quietly through memory once more, ancient astronomers tracking its slow motion, Galileo sketching its strange ears, Cassini orbiting for 13 years, all connected through centuries of curiosity. Saturn has been continuously observed for over 4 centuries with telescopes, each generation refining understanding, each discovery building upon the last. You begin to feel how Saturn represents continuity, from ancient skywatchers to modern spacecraft to future missions yet to launch. Its orbit continues, uninterrupted. Saturn completes one orbit every 29.5 Earth years. Every time it returns to the same position in the sky, decades have passed on Earth. Children grow, civilizations change. Yet Saturn remains steady. You sense how its rings may not last forever, how its storms may one day quiet, how its internal heat will slowly fade. And yet for now it shines, encircled by ice, wrapped in haze, guarded by magnetism. You drift one final time into stillness, watching Saturn glow faintly in reflected sunlight, its rings forming a thin, luminous line across the darkness. And you feel how this distant giant embodies both motion and calm, complexity and simplicity, grandeur and silence. A planet that has existed for billions of years and will continue its slow, patient journey long after human stories have faded into history. And as you remain calm and weightless in the vast quiet of space, you sense that Saturn does not demand attention. It simply exists, steady and luminous, turning endlessly beneath its crown of ice. A silent giant circling its star in timeless harmony. You drift into one final stillness, allowing Saturn to rest quietly in the distance, its rings forming a delicate arc of light that seems almost impossibly thin against the vast black canvas of space. And you begin to sense how this world, so immense and powerful, carries itself with a kind of quiet dignity that does not demand attention but rewards patience. Saturn's mass is about 5.68 times 1026 kilograms, an almost incomprehensible number. Yet that mass holds together storms, rings, moons, and magnetic fields in stable harmony. You sense how everything about Saturn is a balance of forces: gravity pulling inward, rotation pushing outward, heat rising from below, radiation drifting into space. Saturn's rapid rotation creates a noticeable equatorial bulge. It is wider at its middle than from pole to pole, a subtle distortion caused by speed. You drift gently along the ring plane once more, ice particles orbiting in perfect obedience to gravity, some bright, some darkened by time. Saturn's rings are primarily composed of water ice with traces of rock, fragments of former moons, remnants of collisions, temporary structures in an ancient system. You sense how Saturn itself formed from the same primordial disk as Earth, the same cloud of gas and dust. Saturn formed from the protoplanetary disk that gave birth to the solar system. Yet its destiny was different, too far from the sun for rock to dominate, massive enough to gather hydrogen and helium, not massive enough to ignite fusion. Saturn is often called a failed star, but it lacks sufficient mass for nuclear fusion. And so it remains a planet, a giant, but a quiet one. You drift farther outward until Saturn becomes small again, its rings blending into a thin luminous line, and you begin to feel how scale reshapes emotion. How something so vast can seem serene from afar, how storms that dwarf Earth can appear calm when seen from billions of kilometers away. Saturn continues its orbit, unhurried, unbroken. Saturn has orbited the Sun continuously for over 4-5 billion years. Through impacts, through migrations, through the rise and fall of worlds, and it will continue. As you remain calm and weightless in the darkness, watching the ringed giant slowly rotate beneath soft reflected sunlight, you sense that Saturn's story is not dramatic or loud, but steady and enduring, a testament to balance, gravity, and time. A silent guardian of structure in the outer solar system, turning endlessly beneath its shimmering rings as the universe expands quietly around it. You drift into complete stillness now, allowing Saturn to become nothing more than a soft golden glow in the distance, its rings a fragile line of light suspended in endless blackness. And you begin to sense how this final perspective is not about detail or discovery, but about quiet understanding. Saturn's beauty comes from structure shaped by gravity. Every ring particle follows a path defined by invisible forces. Every moon traces an orbit calculated by mass and distance. Every storm spins because of rotation and rising heat. Nothing random, nothing wasted. You sense how Saturn represents balance on a cosmic scale. Immense mass yet low density. Rapid rotation yet slow revolution. Active storms yet tranquil appearance. Saturn is the least dense planet in the solar system. A giant that could theoretically float in a vast enough ocean. A paradox of size and lightness. You drift gently along its orbit one final time, nearly 30 Earth years for a single revolution. Entire human generations pass between one Saturnian year and the next. One Saturnian year equals about 29. 5 Earth years, time stretches here, slows, becomes expansive. You sense how Saturn's rings may one day fade, how its storms may weaken, how its internal heat will gradually diminish. Yet none of that changes this moment. Right now Saturn shines, encircled by ice, guarded by magnetism, accompanied by a family of moons. Saturn has more than 140 known moons and moonlets, a miniature system orbiting a giant world. You begin to feel how Saturn teaches perspective. From Earth, it is a point of light. Up close, it is a vast and layered system. From even farther away, it becomes a quiet jewel in the darkness. And beyond that, it is one planet among billions in a galaxy filled with countless stars. You drift into silence. No storms, no data, no measurements. Only a distant golden sphere slowly turning. And as you remain calm and weightless in the endless night of space, watching Saturn continue its patient orbit beneath a crown of ice that gleams softly in reflected sunlight, you sense that this ringed giant does not need noise or spectacle to command wonder, because its quiet endurance across billions of years is itself a kind of cosmic poetry, steady, balanced, and eternally circling its star in serene and silent harmony. You drift one final time beside Saturn, allowing the ringed giant to glow softly in the darkness, its storms turning quietly, its rings shimmering faintly, its moons tracing their endless paths, and you begin to feel how this journey has not only been about facts or distance or gravity, but about slowing down, about expanding your sense of scale, and about letting your mind rest within something vast and steady. Saturn remains one of the most visually stunning planets in our solar system. Yet beyond its beauty lies structure, physics, time, balance. Everything we explored, from metallic hydrogen deep within its core, to helium rain slowly falling through immense pressure, to the hexagon spinning at its pole, to Titan's methane seas and Enceladus's hidden ocean, exists together in one coherent, gravitationally bound system that has endured for over 4.5 billion years. Saturn formed around 4-5 billion years ago and continues evolving today. It rotates rapidly, it orbits slowly, it radiates heat, it reshapes its rings. It guides its moons, and through it all it remains silent. As you picture Saturn now, small in the distance, wrapped in its luminous rings, you may feel how calm something so enormous can appear when seen from afar, how storms larger than Earth can look gentle from billions of kilometers away, and how even a giant planet becomes a quiet point of light in the infinite scale of the universe. And with that image resting softly in your mind, we reach the end of this journey across Saturn. Thank you for watching. Thank you for listening. And if you are still here with me at the very end of this long and peaceful exploration, I truly appreciate you. If you enjoyed drifting through the solar system together, I would be very happy if you consider subscribing to the channel, so we can continue discovering the other planets, the mysteries of space, and the quiet wonders of the universe in future videos. Feel free to like the video if it helped you relax, and let me know in the comments which planet you would like to explore next. For now, let Saturn continue its slow and endless orbit in your thoughts, and let the calm vastness of space carry you gently into rest. Good night.